Day 14 of cracking 500 AI and data science interview questions challenge. 5 questions a day, 100 days. One step closer to your dream job. If you're new here, don't forget to check out the first 13 days in the playlist. You might have missed some key questions that will be important in cracking your next interview. If data is fuel, future engineering is the refinery. Raw values need to be transformed to unlock real insights. What is feature engineering and why is it important? Your model is only as smart as the features you feed it. Feature engineering means transforming raw data into meaningful input for a machine learning model. It is not just cleaning, it's creating new variables or modifying existing ones to capture useful patterns. Extracting the day, month, or weekday from a date column is one of the example. Similar to that, turning text into word counts or sentiment scores, creating interaction features like price and discount. A well-engineered feature can outperform a more complex algorithm. In one project, adding a total item spot and past 30 days feature improved accuracy more than switching from logistic regression to XGBoost. What is the difference between one-hot encoding and label encoding? If your model can't read text, you teach it using numbers, but the way you teach matters. Both techniques of one-hot encoding and label encoding convert categorical variables into numbers, but they work differently. Using label encoding, we can assign a unique number to each category. For example, for red, 0, for green, 1, for blue, 2, which is simple and compact. It implies order, which can mislead many models. To deal with this drawback, we do have one hot encoding, which creates a new binary column for each category. For red, we do have values like 100. For green, 010. It works similar to a logic gate, which is safer for models like logistic regression or decision trees. It can increase dimensionality. Use label encoding with tree based models, which ignore order, and one hot encoding with linear models. What are some techniques to reduce high cardinality in categorical variables? If you have too many categories, you're not feeding the model, you're flooding it. High cardinality happens when a feature like user ID or product name has hundreds of thousands of unique values. If you have too many categories and it has more features of the encoding, it will definitely reduce the speed of training and you have a risk of overfitting. But how to reduce it? We have three different methods. Frequency encoding. Replace each category with how often it appears. Second method, target encoding. Replace each category with the average target value. For example, average purchase rate for a product. Third step, clustering categories. Group less frequent values into other. In a retail project, we reduced a product ID column with 2000 plus values into just 20 groups by aggregating products by category and price range. How do you apply one-hot encoding using Pandas? Want your model to understand categories? Let's give it binary classes. This is our raw data. The color column is a categorical feature. PD.getDummies turns the color column into three new columns: color blue, color green, and color red, filled with ones and zeros. Each row has a 1 in the column that represents the original value. How do you create a new feature from a date column? Dates hide so many signals. Pull them out and your column will see them in action. Let's say your data set has a purchase date column. This code will convert the column to date time format so that you can extract components. And it will also create two new features: purchase month and purchase weekday. Using purchase month, you can create wall months, which tells seasonality. Using purchase weekday column, you can talk about the 7 days of a week, which tells day of week buying pattern. This will add a binary column. 1 if purchase was made on Saturday or Sunday, 0 otherwise. Today's pro tip: smart features make simple models powerful. Feature engineering is not just math, it is storytelling. You are telling your model what to focus on. So clean, create, encode, and most importantly, think like the data.